Hello guys, welcome once again. So last video we learned what a bank is, and we look at the functions of a bank, and with that we want to use those functions to define what a bank should be. So we listed out all the functions, we drew a simple architecture, and we decided to use the architecture as a building block to implement a contract that gives a traditional bank a decentralized presence. So we did a lot of dirty work, but then we're going to review the contract once again. Sorry, going to view the diagram, the software design architecture, which is this. So we've implemented some of the functions here. So a bank, going over it again, has a means of depositing funds, has a pool where the funds are locked, has a payout, so you can access the pool via the bank, and you can actually apply for sort of a loan, and an interest will be calculated against that loan. So we're going to be taking it, like adding some stuff here. Yeah, definitely going to add a lot of stuff, update stuff before we push it to testnet. But before we do that, we're going to write a lot of tests, and the reason why we're going to do that is because we don't just want to have a package published to the testnet when it is not having all that it needs to satisfy it to be standard. Okay, so yeah, so let's take a look at what we had. So this is it. I'm going to expand this a bit, then bank. And by the way, the link to the GitHub repo is going to be attached to the description, like in the previous video, so you can seamlessly look it up and see what we're doing. Now this is it. I want to reduce this a bit. So yeah, this is the bank. There are some struct that we've declared earlier. We'll have the account struct, pool struct. This account is your on-chain bank presence, right, which is a bank account. This pool, then pondering through the whole architecture, this pool should have a name. I thought of this pool should be named something, right? So we need a string, a name, sort of, to identify this pool, right? Yes, so that implies that wherever this pool was actually used, or yeah, we'll have to like pass a name for it. So upon creation, we want to give a name. We'll pass a string. Yeah, pass a string, call this name. Yeah, so the pool has a name. Yeah, and I think that's the little update I have, right? For me, I would want to do that because the uniqueness is already by the type. All right, so that's it. Then we already have a feature that has to do with creation of pool. We have function that has to do with creating an account, making deposit, and we want to implement the function that has to do with withdrawal, right? So withdraw, right? You have to withdraw a coin of type, yeah, and so this is it. then yeah, conf type skill. So now I have to specify an amount. This is the 4 of to, but then I don't really like passing in arguments this way because I might not be exactly accurate with the argument to passing, so I go straight up from the logic to see what arguments will be needed. So I think that's a very good approach for myself to see what I should pass in. That implies I'm going to take out this type here. So so this is simple now. So what I want to do right now is this, very simple. So I want to withdraw. The first thing I want to do is to assert if whoever that is implementing this has a balance, has enough balance to withdraw first. So the person is withdrawing an amount. So we're going to check the amount. If this amount is less than balance, let me check it, less than or equal to the balance, right? So what I want to do is, before I do that, I'll need to get let's check again. So there's nothing on the pool, so yeah, cool. First off, I have to check if the account is greater than or equal to, okay, balance. Yeah, this is a balance, right? Sneak peek from here. So I'll check if my balance is greater or equal to the amount I want to draw. Right. For then, there are going to be some service charge. So since there are going to be some service charge, I don't know, I wouldn't want to take every of the balance, right? It just strictly has to be greater than, right? Yeah. Then if this fails, I'll write something here. I don't know what to call this right now. So this is cool. Insufficient balance. So I want to come here and say A, insufficient balance. So that implies that I need to pass in an amount. This is 64, and an account. Here, or CTX. I think that's the simplest way. So then there's nothing that has to be checked, right? So we need to see who is performing this transaction. Once, because anyone can feed this object into this function and run up a transaction. So there has to be an authentication to show that the people that only needs to withdraw are people that have an account. Yeah. So simple. So we need to do an assert. She said, why 30 cents is just annoying. Yeah. I'm gonna assert if count dot, let me see, count dot, the number has to be the sender, else you can't. Yes, sticks recipient mismatch. Okay. Recipe mismatch. Okay. So okay, it's already implemented. So now we've known that the owner of this account is the one trying to make this transaction. So we assert that he must be the one trying to call this transaction, and it's going to pass the object, and so next we want to check if they have sufficient balance. Then if they have sufficient balance, we want to start it again. So the first thing I want to do first is to reduce the balance. Yeah, we want to do this, want to reduce it, right? Then after making that reduction, we want to move that coin from the pool. So we need to pass in the pool here, so we'll be able to access it. That implies we have to get this back again. Don't do that. So we have to get the balance from get coin from pool. So now balance. So I like checking this again. Analysis, balance, find speed. It's gonna return a balance. So balance of times speed. Speed takes in the balance itself and the value. So we're going to pass in pool dot balance of the pool. Let me see. Yeah, have a balance. Okay. Balance of the pool, and let me see. It has to be immutable. Yep. Passing the balance of the pool, and the next thing I want to pass in is the amount. This doesn't have mistakes, don't see, or she doesn't. So we want to put the amount in here, right? So with this, we'll split it out, getting the coin. So what we want to do next, since we've gotten the coin, have to transfer that coin to the destination address. So we have to convert the coin to balance the coin. Okay, so balance the coin. So we'll find a function and see how it goes. The coin. Let me just Sorry, I really forget this. I guess I'm being lazy. So really forget it. Because I guess always here. Okay. How do you mean? Interesting. Looking for a function. Okay. So I think that function is here. It's a coin. Just one. Nah. Interesting. It's a balance. So it's into coin has to be here. Just two. So I'll just go back to coin. Let me see what's been passed in. Nothing. So right now, so right now I have the coin here, and we'll transfer. The coin. Yeah, this. So CTX is sender. Yeah. So I'm sending to, let's respect ourselves. So withdraw. So now it is good to actually be flexible, so that implies I have to put a recipient here. So this recipient gives me the ability to, I can withdraw to any address I want, but for me this is a security vulnerability, right? But then let me evaluate this function to see that regardless of if I decide to put a recipient, this system can be gamed. So first off, it checks if the caller is the owner of your account, and if they succeed, the next it checks if there's sufficient balance in your account, and if it runs it right. And the next thing it wants to do is to reduce your balance from your account and take out the token from. So all these already is okay. So now I want to take the recipient. It should work. Okay, it should work. Just a sec. Alright, back. So yeah, so I want to save this. I don't have any intelligence here that tells me how my program behaves, so I'll definitely have to build everything to see what is broken and what is good. So if it is broken, I see it and I fix it from the compile. If it is good, I see it as well. There's an error that will be thrown out. So let's patiently wait. Yeah, so definitely there's some errors. 87, 64, I mean, yeah, and 86. Now let's go split. Okay. I just need to put this. Now this is important because the rate just applied to the pool. I can update the pool, but then the balance itself needs to be updated. That's why I need to pass in this. So it's just simple. So at this point I'm not passing the pool anymore, I'm passing the balance, and it's not being mutated. There is no keyword to say I'm changing hue. Right, that's fixed. The next this was just copy. Okay, I think that should resolve this. So then invalid sui expected to got one the coin. From balance 87. From kind of looking at this. Okay, there has to be a coin type. Yeah, okay. Then let me just read out everything again. It's supposed to automatically get that expected to got one into. So let me just check this again. See all the arguments. Fine. So one of one. Just one function here, and the API doesn't specify passing anything, so let's solve it with our brain. So let balance to coin get coin from pool dot into coin everydays. Found an argument, that's self. Valid call of this call expected to argument, the argument when stated. But then this is what it is there from balance. Okay, so I am going to do from balance and see if there's any guy like that. It's from balance obviously, and it takes in balance and CTX. So what is missing here is just CTX. So I need to put in CTX here. Just this way. This should work because CTX is already mutating. So I need to view it now. Yeah, works now. So with this function, been able to implement deposits. Now we can do a payout to anybody. We can take out from the pool, like you see in the logic, taking out from the pool, which is here, passing the pool, and yes, and there should be a way to, I'm looking at something now. The pool name should be actually the type. How do I do that? So to make sure that I'm taking out from the correct pool, there has to be something that points this my account to the actual pool, because what I'm doing is just keeping balance, right? Then the account has a number, has a balance, but the balance is just a number. So that implies that my account needs to have a type. Yes, it's gonna be a phantom type of T, which is to tell you that okay, what you're doing here is this type doesn't need to be used like in the attribute of the struct. It can just be explicitly stated here, giving a type that wouldn't worry or affect the build. So let me update in every account I can see. So in here, I'm supposed to return an account of type, so I can have different accounts for different currencies. So I'm going to have this as well, and these. Now I want to deposit funds, right? The deposition has to be of that same currency, yes. Then withdrawal has to be of the same currency, yes. So it means that you cannot put an account of different, that means we cannot do something like this. Yeah, we can actually do that if we decide to pass in another argument this way, but if we do this, this is catastrophic. This means we can have inconsistency when we remove funds from an account of a different currency, right? Changes the balance and remove funds from it, so it has to be correspondent. So we're not doing this, have to keep it consistent. So this has to be T as it is here. So I'm going to beat again. I needed to fail one more time, so then one that's okay, didn't fail. Cool. So this implies that you're making a withdrawal and the account that you're withdrawing against, you pull out the same type, then meaning the account of a currency has to be interacting with the same currency of pool or treasury. Now back to this. So to some extent we'll fix the payout, and the only payout we've done or implemented now right now, it's a payout that has to do with withdrawal. I think we're supposed to implement a payout that has to do with calculation of interest. Alright, but before we do that, there are one or two things we need to tighten up. So the deposits, this shows that the recipient is this, so this is, you actually do the right deposit, but the big catch here, you want to actually make sure that the amounts you're depositing makes sense. What do I mean? So the amount of deposition amount must be greater than 0. Now that's cool, but then we don't want to perform a transaction whereby we're going to charge you. Definitely there's going to be service charge. Alright, so now if it's greater than 0, right, also it has to be greater than the service charge. Yeah, cannot make a transaction now. I mean, the service charge is taken out and nothing's been deposited to the phone, right? So I can make it flexible and you can start off from any amount, but I can decide to make sure that the position is going to start from, okay, so we're going to start from 5. So you must have up to 5 to actually bank with us. So 5 of whatever token or whatever balance you want to do here. So I'll just go in straight and do that. So I've asserted that this is 0. Then the next thing I want to also check is the amount is greater than the service charge. Service charge, let's keep a constant service charge. Okay, service fee. So the service fee here, I want to take just one sui. No, that one sui is over, I think 9 decimal place or 6 decimal place. I should remember. So yes, that's what I want to do, because that's going to come in as the actual value. So that's what we want to do, right? So I want to create a base. This conversion, this is the form. What I think is yeah. So this is one sui. So how do I write out the one sui here? Very simple. So this is one sui. So one sui is going to be converter. This converter by service fee. So trophy charges, so it has to be trophy charges, valid amount, that is implemented. So this now we can actually check But oh, the amount you're not just saving, like you're not wasting out our gas fee, and you can pay for service and still save something. Now we need to remove this gas fee and send it somewhere, but then I don't want to deal with that logic right now. It'll be much later, so everything will seem very well. So we've implemented the deposit, we implemented withdrawal. Is there anything missing out? I feel there's some things I need to correct for the previous algorithm. I think that's it, and I think that's it. So control. So we can deposit now. We can make withdrawals. Everything appears. So now for the interest part, for we to interact with this interest functionality, we need to create a system that allows people to borrow money from here when they don't have. Right? We need to have a system that allows people to borrow money from when they don't have, and they will pay some amount of interest. Okay, so for that, check. Okay, cool. Yes, I'll do that right now. So these individuals need to apply for loans. When they apply for loans, system will automatically evaluate them, their fit. Purely decentralized. So there must be some set of users that should be able to apply for these loans, right? So there are some things we need to check: the ability to pay back. So, but then apply for loan simply means collecting. So I just want to write the loan, but then I need to calculate. I need a formula, right? So formula to calculate interest in chart file. Yes. There's a formula: interest, principal, the head money, the rate, and total interest, principal initial amount that was given, annual returns, and the time. So we're dealing with compound interest here. So then the compound interest time is around years, but then we want something very small that calculates principal times the annual rate over 360 times day. So this is what we want to do. Right, this is what we want to do. Outstanding principal balance. Yeah. Let's make this a bit okay. There's no need to do that. Number of calendar days in the period. Alright. Okay. So the standard principal times annual rate times number of calendar days in the period. Number can be like 30 days, right? So let's give interest of, let's give round out to span just 30 days, right? So once call this D 4, let's call this 30. 30 is like how many epoch? That's ask a quick question. Epoch is the day. Yes, let me confirm. Epoch is the day. It's actually 1 is supposed to be 1 to 24 hours. Let me confirm. Alright, cool. Now, so let's start the epoch. So this is going to be number of calendar days. Period is usually default to that, and the next thing I want is the rates. So rate is going to be how do I do that rate? Rate is going to not be constant, right? Well, let everybody have the same kind of rate. That's what I want to do. So 10, then principal. So simple. So this is going to be standing principal balance. I think this is supposed to run per day and reduce actually. That's how that formula is supposed to work. But I'm going to use it anyways regardless. So then this needs to count every time. Someone needs to like call out this function every time so it computes. So to be on the safe side, let's just do simple interest. Total interest and alright, and principal initial amount and honor rate and time. This is time years. Fix this now. The rate is constant for everybody. So this is a function. So principal initial then this is for calculate it. So instead of we're going to do a conversion around seconds. So instead of us having just days like this, right, 30 days, so we're going to use a constant conversion for time. We're working with seconds instead of, right, so instead of having decimals here, you have seconds instead, right? So let me quickly check up something. Yeah, only what I have is assigned integer, always going to be positive. Alright, so we're going to do multiplication or true. Alright, so this is what we're going to do. So this function definitely be called every time from the front end, right? So because our calculation is p times r times t, so we're going to get the interest, calculate interest rate. Right, so we're supposed to get 64 back. So excuse you. So principal times, yeah, no, then we're going to do rate and time, which is t, yeah. So this gives me interest rate. Now the interest has to be result, so I need to apply for a loan. So there are certain customers that has to be given this loan, so I have to write a function that I can only call as an admin. Did I create any admin area or admin cap? Let me check. So CFO cap, but then this now has to be about CFO creating an admin for managers. So managers can actually allow people that owns an account to have the ability to loan money. So after this has been created, the manager should have the ability, the CFO should have the ability to enable managers to create managers, right? So create manager, so simple. This is going to give me a manager cap, struct manager cap as key, this way. So manager cap, manager cap. So if this is more of a protocol, I think okay, I can call it and still take it away. I mean, I don't want to transfer it. So what's my criteria to be able to call this criteria? So the only person that can call this is just CFO. So the CFO creates managers, right? So the managers can now do something, which is to after evaluating the record of an account holder, they cannot say, okay, fine, let's give you the ability to get loan, right? So I mean, those guys can take loan, but then there have to be a tier, some sort of limitation. But then let's just create a cap to be able to like take loan, right? Loan cap. So gonna call it loan cap, create a struct called loan cap. Yes, this way. So the managers can come down here and create loan cap. So creating this loan cap, who can do this The manager can do this. Now, this loan cap needs to have there has to be some marks, right? And marks like what the loan cap could do, max amount, can actually call it a policy. So the loan cap is not just hanging there. The loan cap has a policy. So we need to put like a cap to this loan cap, so it don't take all our money. So all we can give them is so now do I make the cap? So making it thing simple is to actually put a fixed amount of what they can borrow, what they can take. So I'm not putting it into the loan cap, but then in the loan function, not in the create loan cap function, in the loan function. So loan function, it is the marks they can take, apply for loan. So I think they're not the one taking the funds, right? You apply for loan. When you apply for loan with an amount, right, it will be shoved into like a database system, so the manager cannot view who wants to take loan and approve the loan, right? So when your loan is now approved, you can now go and take the loan. So if the loan is approved, you take the loan. Okay, getting more comfortable. So these guys need to apply for loan. So loan cap, yeah. Yes, for the principal. Principal. Yes. So apply for loan or create loan. Yeah. Oh. This loan should contain my account number, currency, and the amount. Alright, so basically loan struct okay. There's the amount. address. Then I'll apply for the loan. Now I need to write a state for this loan, so I'm gonna do that with an email. Defaulted, paid, so if it's still pending, loan should be unapproved. Unapproved. Should be if it's not unapproved, if they've interacted with it, it should be cancelled. So it was not approved. Then if it is, so it has to move from pending from unapproved to cancelled or active. Then I can actually change it to 4. So this loan should sit in a DB, right? So yeah, the loan book. Is good as key. Loans. Vector of loans. The problem now is I can't use this loan book so I have to create a new loan book. So there's going to be different types of loan book everywhere, right? So you have loans. It's going to be a front now. So this is what does I want. So we want to create loan. We'll create loan right now. So let's quickly grab what is here. Go down. Put it here. Very good. This is how it should work. After the loan has been created, I smart. Yeah, algorithm is bad. Principle. So, yes. After the principal, right? We want to create. So we also like it's supposed to be like a loan. Which currency every pool that has been created? Let me see where the pool has been created. Create pool, create pool, create pool, create pool. Yes, you need to create a loan book for it as well. Yes, be a loan book for it as well. So um so we can loan book. Yes. So from here, loan book, we can push this loan this way. Yes. Very good. So we can push it this way. So this we've created a loan. So we can this is it. So we can with this so in calculating the rate we need to pass the loan itself, right? One is the loan that was created, and we're just reading from it this way. Yeah, so yes, that's what we need to do. Yes, so very easy peasy. After spending, so right now he's account holders can apply for a loan, and we need, so they can only apply if they have the loan cap. So people that should call this function have loan cap. If you don't have, you can't call it. Then next thing is we need a system for not just approve loan, to read loans, right? Read loans. Who can do the reading of loans is managers. Manage cap, read loans. So what do we do now? The loan book. We need to go through the loan book and look at the loan. Or we can seamlessly look at it from chain. But this is supposed to provide a source of truth where they can see loan book. Yeah. Loan book is peculiar based on type. Loan book is peculiar based on type. Yes. Check that. Yeah. So this right. So look up loan book. Yeah. Type. So type C. Type T. Sure. Further. Now there's just be some little errors, but then let me reduce to the little I can. So there are some checks we're going to look at and implement. Everything will go gradually. So so I'm taking loan drum book. Loan book. So it's going to be book. Just read. What's in one nice? Just read. Now it's so I want to iterate, don't stress the chain. So vectors of loans. So that's not what it is. It's going to read, right? Let me see what I have back there. Expecting some very lengthy stuff, very lengthy errors. Yeah, expecting some very lengthy errors. Oh, cool. Then key abilities is what others. So this is in yes. So I need another yes. Then so the two compound wasn't you create it there. Yes. So okay, those are the ability key. Can't have the ability keyboard. Type C does not have the ability. A notebook needs key. The same. Yes, it does. It's key there. It's low. There's a key there. So yes, so that then all for one compound. Yes. expected a local constant but found known in scope. It compacts a lot of types. Okay. 153. Yeah. Let's see something. So. Yeah. So loan. Okay. Around 5 now. Okay, we have less. Oh, yeah, it's less actually. Then this needs a store ability. Six. Okay, the bank loan needs store, so it can store some stuff. Can have another asset, another struct in it. Then 1991. I did that. It's not a problem. So yeah, suppose we push back 156. So okay, so the last one is calculate interest, no evaluation. Yes, this is again expected. let's see, we'll have some fractions of little errors. Missing argument, what field are you in? 89. Yeah, so 90. Yes. And what else? Copy. Valid infinite copy of target probability. Actually, I want to copy versus 1. We don't copy what is inside the content, but we can put a reference to show you're reading it. Alright, it should work. Okay, so it's telling me unbound constant t. Okay, is it constant t? Yeah, exactly this one. Right, 168. Yeah. Why is that? Okay, same issue. I think that's supposed to be the issue. Guess not. Let me try. Now, I'm left with just a single. This it's never used. Like I called it here. Uh-oh. They said constant T is never used. Interesting. How I used it and it was considered never to be used. Wow. Let me check. Up. All this on check. Something. Bound T. Oh, I understand. That implies I can use. Oh, cool. I like this. So that implies I can actually call the name of my pool. Let's go back to create pool again. What's the name? I'll do this. So unbound. It's going to show unbound. Okay, let me see if it's achievable. Okay. Take something. Oh, string. That's a lot of stress. Something is playing in my mind now. This. Check them if it. That's the reason I want to check them if you don't see how you can use std strings strings and write something into it. Okay. I can fix that for now, so it doesn't take much of a time. I've cleaned around this area. Shut down like this. I guess is around the area where I did that. Append substring. Okay, this is it. So take this or pen something. I think that's cool. So what I want to do first is I want to say L name, right? Pull name, equal to E. It's a string. Just this was simple. Then then the V full name. Not that way. Take this off. Excuse me. So I put append. Pen. So I take this guy here, just this way, append. So pen. Got it now. Oh, got shot myself again. Trying to push in this T as the name. Let's see what happens. Let's just see what happens. Gonna blow up. Okay. It's gonna blow up. First I didn't pass in here. And it's blown up already. Yeah. It's not going up yet. Bound T is just a type, so let's just fix the little so I think it's to call this guy completely time, right? And these rates, right? Save them, go down if you need it. See rates time. Let's view and see. We should work now. So yeah, so managers can see the loans and they can write the loans, right? So I want to know, want the manager to update loans. Okay, update loan status. So this is then this getting the loan from, that's not really the logic. That's not really the logic. So we'll have to check the loan book. The loan book houses the loan. Let me see. Yeah, that's not what I want to do. Loan status is here. We don't want to go through the loan book, just want to pick up that loan itself. It exists, right? Take the loan and update it to work. Obviously it will. So after checking, manager can update the status. So just take loan status and manager can status and quickly look at how, so yeah, you can choose whatever status you want, pass it in here, right? And that has been updated. So I don't know why. Invalid mutation requires a drop. Let's see. So see. Okay, I think we need to add a drop here. Let's see how it goes. Yeah. So, what's this 5 saying? Consider moving prefix. I don't want to do that. Yeah, so this is 5. Why is it date when I take it off? So that solves your problem. So in the next video we're going to be writing a test to see how all this behaves, right? See how all of them really behaves, and we'll see how it behaves and it's satisfying, make some tweaks, and we'll publish the contract and play around with it. Thanks for tuning in with me. God bless you.